Well, howdy everybody, welcome. Another edition of That's Railroad. Yeah, well, we bring the railroad to you, and we do love doing it. We've got a kind of a unique, well, a different type of show today. We've got a special guest on our show also, and we're going to give you a little bit of railroad history and show you something that you don't see on the railroads anymore. Okay. Okay, what we got here, we're up here at our milepost 8 siding, and this is a siding track over here. I just got off rail. I got a train leaving up the plant, so I had to get off rail, plus it's my lunchtime. But anyway, let's assume that this siding track is another main. Let's say we got double main here. All right, so this siding track would also come down here. If it was a main, keep on going behind me and out ahead of me. Now, if we wanted to go from one main to the other main, what we would have is a crossover, what's called a crossover, from one track to the other track. All right. The difference between a crossover and an interlocking. An interlocking is a crossover from one main to the other, and that crossover contained a set of signals, a signal system. That signal system would have lights and also interlocks to prevent the switches from being thrown in the wrong position. So a train from this track couldn't come down and cross over onto this track if this was a red block. Okay? So that's what the Pennsylvania Railroad said. If you have a crossover between two tracks without a signal system, it is a crossover. If it had a signal system, then it was called an interlocking. Anyway, that's the interlockings are all, it's a very complicated electrical system, and we're not going to go over that today. But it does prevent the switches from being thrown in the wrong position. Keep trains on the right track. All right. In the days of old, I told you Pennsylvania, I believe Conrail also carried over that terminology of what an interlocking was. I believe so. But in the days of old, and like I said, those are all controlled computer now. But in the days of old, you would have either a manual guy go out and actually throw the switches, or very often they had switch towers. Where a guy in the switch tower would throw the switches for the crossover or the interlocking. And today we're going to go over a little bit about how the guy in the switch tower threw those switches. Okay, this is pretty interesting. Anyway, the next part of our show here, we're going to have a special guest with us, and he and I came in early before. He's not an employee here. He loves our operation though, but we came in early before my shift started and taped the next part of the video before I clocked in for the day. Okay, so I hope you enjoy. It's pretty interesting, I think. Okay, good morning. We got a special guest here. This is Mark, and he goes by the username of What Do I Do Next? Mark is the one that made all the drone videos on the transport of our new MELX cars. So he's here to show us a very unique thing. Anyway, welcome, Mark.
Welcome. Morning.
Okay. And he brought these. So he's going to explain what these are right here.
These rollers were part of a rod-operated interlocking tower.
Okay.
The interlocking tower could have been a pneumatic plant, a pistol grip plant, or an Armstrong lever plant, but you still had rods going from the interlocking tower outside the tower
Mhm.
down to the switches.
Okay, and these are what the rods would roll through, right?
Exactly. And
Pretty neat stuff.
sometimes you would have one, almost like you'd see here, except they would have a galvanized J-bolt underneath of it, hooked to a length of 1-inch galvanized pipe, which was mounted onto a concrete block.
Okay.
And the rod was also a 1-inch galvanized pipe, and it would rest on these rollers,
Mm-hmm.
which actually, besides rolling, had a length of travel of about 3 inches. So
See that in there?
as the rod moved over that roller while they were throwing the switch,
Uh-huh.
it would travel.
How about that?
Same thing on the top. The keeper has a roller that also rolled. These bolts would actually be cotter pins. I don't know why I put bolts in, but I did. Now on
All right.
the interlocking plants, you could have as many of these going across
Okay.
as you wanted or needed. All you had to do to extend it was to take another one of these brackets. The bar here has a notch in it which secures it here
Okay.
and then interlocks with the rod on the previous roller.
You see
You
that or not?
probably have to take that off sometime or
Well,
something.
okay. That's how it goes in there.
Right, you can see the keeper here, which would fit in that notch, and they would interlock together.
Uh-huh.
So you put one of these on, you put another one of the rollers on the carrier.
Can we hold that for you?
Sure. Thank you, sir.
And
And
that's how they go.
the neat thing about these rollers is they would wear out. These bosses on the end
Mm-hmm.
would taper off or just wear out, and the roller would drop out. So to replace it, you can go from either side and simply drop it
that?
in, and again it would spin, roll, whatever you want to call it,
See that little groove right there?
to help enable.
That's how we
The
drop
travel.
it down in.
Now this particular set here is marked for GRS, which is General Railway Signal Company.
Wow, cool.
This particular set here isn't, and the castings are slightly different. I'm not sure what other manufacturer there was. Could have been Western Railway Equipment or Western Railway Signal. Who knows? Someone else viewing will have to enlighten. But
I don't know. That's pretty informative so far as is.
But this is this would be an example where you could have 3 rods. And I sent you pictures of the interlocking plant that these came from,
Okay.
and it can show you how far the pipes, the rods
Yeah.
could travel. And even bend or whatever to the profile of the lane.
Right.
And there was
Yeah, that'd be cool. You can send me them pictures and I'll put them in here.
yeah. And there were other components, but
Do you know where this came from exactly then?
this came from the interlocking plant at Hardman, West Virginia.
Okay.
It was a plant owned by, well, operated by the Baltimore and Ohio Railroad, just out of Grafton. There was Grafton, there was GN Tower, and then the next tower was Hardman. It was a helper station.
Okay.
And they also had a small yard there where trains could double the hill if they needed, or they could just set off helpers. But it was obviously a rod operated plant, and they would take that up up Newburgh grade past Newburgh, West Virginia.
Oh, sorry about that.
All the way on up to Tunnelton, West Virginia, and Blazer, where the helpers would cut off and run back down the hill either to Grafton or to Hardman.
That was quite some time ago, wasn't it?
Unfortunately,
Yeah.
it was a good while it lasted. I got to see it during the Chessie era.
Oh, cool.
Yeah.
Yeah. Wonderful. Okay. You got some pictures there you want to show too.
I do. These
Let's see what we got here.
now these were from Hancock, Maryland interlocking tower whenever they tore it down.
Mm-hmm.
And excuse me, as you can see, the 1-inch rods that these carriers would sit on with the galvanized J-bolts, and then these brackets, which you can see several of the brackets here.
They're up here.
Yep.
Okay.
Would bolt onto a concrete pedestal in the ground.
Neat.
And I sent you some from Hardman on that also. This contraption here, if this pipe were swung around the other way, it would reverse the direction. If you pulled on this rod, the double bell crank, you're pulling on this, but it would send the rod the opposite direction.
How about that? It's quite a contraption, isn't it?
Mm-hmm.
We don't have any of those, but just pictures. But
It was all mechanical advantage.
all right, the guy in the switch tower controlled everything.
Yes.
How about that? I bet that was fun in the winter time, keeping all that stuff thawed out.
Very much so. Yes, sir. Very much so.
Oh, we got another one here. I didn't see that one.
This is a single bell crank, and again on the pictures at Hardman, you will see this at the very end of the interlocking plant where the rods are for the last switch, and
No,
it would just transfer the energy 90 degrees.
this plate here, it would have bolted down to a tie or something like that.
Right.
Okay. All right, great, wonderful.
Yeah. Well, thank you, Dave.
All right. Well, thank
Appreciate
you,
your
Mark.
work on the railroad. I appreciate your channel. I appreciate the subscribers keeping the channel active.
Okay. We thank you very much for your information today.
Thank you.
All right. Thank you for watching. Have a really good day. That's railroading, huh?
That's railroad.
Yeah. Okay, what's that, Mark?
This is the interlocking tower at Hardman, West Virginia, right here in the distance, and you can see how the rods come around from the plant and around and down, and of course, as the fewer number of switches there are, the fewer number of rods there are. And this is one of the bell cranks that changes the direction 90 degrees, so it would push that push that bell crank down, which could push the switch points over or pull them back.
Neat. Okay, very good.